Hello, we are back for Chapter 9. In Chapter 9, we are working on hypothesis testing. Throughout this entire chapter, I want us to focus on how this relates to court trials. So if you think in a typical court trial, we have a beginning train of thought. We always consider the person to be innocent. And it's the idea of innocent until proven guilty. That means that the idea of innocence is our null hypothesis, which we are going to call from here on our HO, the null hypothesis, the hypothesis you're beginning with at time 0. Now, until we prove them guilty, that's what we're trying to build evidence for. We build evidence towards their guilt so we can prove them guilty. That becomes our alternative hypothesis. And we are often going to simply refer to that as ha. So we have our ho and our ha. You are innocent, that is what we were beginning with, and then we're going to try to prove you guilty. Now as soon as we take this and we build on it and apply it to statistics, we're going to say our null hypothesis, our ho, is always a statement of equivalence, meaning you're going to have an equality there. Maintains the status quo, and it's a statement of no change. If everything just stayed status quo, everything stayed as it is. The alternative hypothesis, our ha, will always be a statement of inequality. Whenever you write your ha, you'll always have an inequality in there. And it states what you think, what you were trying to find evidence for. And it always is going to come from the wording of the question. So the null and alternative hypothesis should both be stated before you start to collect data, and they are both statements of the parameter. So when you're talking about your null hypothesis, you'll be talking about the true mean of your data or the true proportion of your data. But you state them according to the wording of the question before you gather any data. And then finally, we're going to use this to go on to do calculations. In the end, you will either reject or fail to reject the null hypothesis based on the p-value and significance level. Again, if we equate this to our court trials, we have our null hypothesis and our alternative hypothesis. If we decide to go with guilty, we say that the person is guilty. But if we don't decide to go with guilty, we never say that a person is innocent. We just come to a conclusion of not guilty, which is basically what we're going to do with this. We're going to reject the null. If we reject the null, then we are going in favor of the ha, meaning we have enough evidence to say that the ha is true or that the person is guilty. If we fail to reject the null, that's equivalent to saying that the person is not guilty. It's not that we know they're innocent, it's just we haven't had enough evidence to prove their guilt. So to see this in relation to some context, hemoglobin is a protein in red blood cells that carries oxygen from the lungs to body tissues. People with less than 12 grams of hemoglobin per deciliter of blood are anemic. A public health official in Jordan suspects that Jordanian children are at risk of anemia. He measures a random sample of 50 children. Now we state our hypotheses before anything begins. Our null hypothesis is always a statement of equality, and it's a statement of status quo. So it should be that people are not anemic, or that it is the way it's supposed to be, which is 12 grams per deciliter. So our ho would be mu is equal to 12. Then our ha goes along with the wording of the question, and in the wording of the question it says that they suspect that the children in Jordan are at risk of being anemic, which means they would have less than 12 grams of hemoglobin per deciliter. So our ha is that mu is less than 12. Now we just keep saying mu there, but we haven't defined mu. So the next thing you want to do is define your parameter of interest. In this case, we have mu is a true mean amount of hemoglobin in Jordanian children. So we have our ho and our ha, and we want to state our parameter of interest. Now I'm going to move this up to make sure you can see it in the screen. Sorry, give me just 1 minute, and we're going to adjust here. Okay, so a Gallup poll report revealed that 72% of teens said they seldom or never argue with their friends. Yvonne wonders whether this result holds true in her large high school. So she surveys a random sample of 150 students at her school. Again, our null hypothesis is going to be a statement of equivalence. So because we're dealing with proportions here, our null hypothesis is going to have to do with the true proportion of people who argue or say that they argue with their friends. So our null hypothesis is going to be that the proportion is equal to 0.72. And then our alternative hypothesis is going to go in the direction that the wording is giving. So Yvonne wonders whether this result holds true in her large high school. So we're just going to check to see. She didn't say if it's greater than or less than. We just simply are going to see if it's not the same or if it is the same. So P is equal to 0.72 as our null, and P is not equal to 0.72 as our alternative. And for our parameter here, we have P as a true proportion of teens in Yvonne's school who rarely or never argue with their friends. Now in the next coming sections, we're going to start to look at how to do the calculations with these. This first one that we had here, we had a less than, is going to be a one-tailed test because it's going in one direction. The second one, where it's simply a not equal to, we're just checking to see if there's a difference, that is going to be a two-tailed test. But those calculations will come later. See you in the next video.